Hello friends, welcome to civil engineering exam. Today we are going to see the problem related with the design of reinforced concrete elements in the topic of bond and anchorage in the reinforced concrete members. So the problem is a cantilever beam having the width of 200 mm and the effective depth of 300 mm supports a uniformly distributed load and is reinforced with 4 numbers of 16 mm dia bars on the tensile side. So if the factored total load on the cantilever is 80 kilonewton, so calculate the maximum load on the bond stress and the anchorage length required. So then third one is average bond stress if the anchorage length is provided as 900 mm. Assume M20 grade concrete and Fe415 HYSD bars. Okay, so now the given data. So now the B is given, that is equal to 200 mm. So then D is given, the effective depth is 300 mm. So then FCK is given, FCK is M20 grade concrete, so 20 Newton per mm square. So then Fy value is 415 HYSD bar, so the 415 Newton per mm square. So then load is given, W equal to 80 kilonewton, so that is equal to 80 into 10 power 3 Newton. Okay, so next thing is LD is given, so that is 900 mm. Okay, so next thing is we can use the IS 456. So now J equal to 0.9. So then tau BD equal to 1.6 into 1.2, that is equal to 1.92 Newton per mm square. Okay, so next thing is we can find out the sigma O, that is equal to 4 numbers of 16 mm bar. So 4 into pi into D, so that is 16, that is equal to 201 mm. Okay, so then AST value, so AST equal to 4 bars of 16 mm dia. Okay, so these are all the given values. So now we can find out the maximum local bond stress. So first question is maximum local bond stress. So now we can use the formula tau B equal to V divided by sigma O into J into D. Okay, so now we can substitute all the values over here. So 80 into 10 power 3 divided by, so sigma O is 201 into J value is 0.9 into D value is 300. So solving this, we got the value of 1.47 Newton per mm square. Okay, so next thing is second question. So we can find out the anchorage length. So anchorage length, we can use the formula LD equal to 5 into sigma S divided by 4 into tau VD. Okay, so now we can take phi is 16 mm dia bars into sigma S is 0.87 Fy. So now we can take 0.87 into Fy value is 415 divided by 4 into tau BD value, we know that 1.92. Okay, so 1.92. So solving this, we got the value of 752 mm. Okay, so this is the anchorage length. So next is third thing. So third question, if the anchorage length is provided 900 mm, so what is the average bond stress? So now tau BD equal to 5 into sigma S divided by 4 into LD. Okay, so now we can substitute. Again phi is 16 into sigma S value is 0.87 into Fy, that is 415 divided by 4 into LD value is given, that is 900. Okay, solving this, we got the value of 1.6 Newton per mm square. Okay, so this is a method we can solve the problem. Again, we'll see next video. Thank you.